Hi guys, this video is in continuation to my earlier video on IPPD. Now in IPPD we saw synthesis of IPPD. Here also you'll be seeing synthesis of 6-PPD. Now here what you are going to witness is all the explorations put in for removing hazardous parameters that were being used for synthesis of 6-PPD. IPPD was being used in tire industries owing to two properties. One was low oxidation energy and the second was blooming. Now in case of blooming, we observe that how the molecule from interior moves to surface to fight oxygen. Alright, blooming is the property of molecule to move from interior to surface. Now doing so, since it had low oxidation energy, so it would get oxidized and protect tire from getting oxidized. So as a result of which the wear and tear of tire would get delayed. But now the blooming property was very intense in case of IPPD. So it would migrate to the surface rapidly. Now owing to which what would happen is leaching would occur. Now what is leaching? Leaching is a property owing to which what happens is the product is detached from where it is attached and carried away by the solvent. Now in case suppose the tire is moving in rainwater. So rainwater, what it does is it detaches IPPD and carries along with it. Alright, so as a result of that there is a loss of IPPD. Alright, so in case of leaching, there is lots of loss. So in case of IPPD, we found that owing to its blooming property, it was detached readily and there was loss of IPPD. Whereas in case of 6-PPD, it was found that the molecule migrated slowly towards the surface. So the loss was less. So tire industries, or rather rubber industries, they moved over from IPPD to 6-PPD, and hence the synthesis of 6-PPD had significant role in our system. But this 6-PPD was synthesized under hazardous condition like pressure of hydrogen, high temperature, and also this project came to us and the exploration was done to get rid of these hazardous parameters. Let's find out how it was tackled. Alright, happy viewing. In case of synthesis of 6-PPD, there are three differences. First is we tried the reaction with ranitidine, but we didn't get the product with MIBK, methyl isobutyl ketone. Now methyl isobutyl ketone, why? This is methyl group CH3 and this is isobutyl group, iso group, carbon to which is attached methyl to methyl iso, and this is the fourth carbon, so it becomes isobutyl ketone, methyl isobutyl ketone. We call it as MIBK in short. So we had to change the catalyst to 5% palladium on charcoal. That's the first difference. Second difference is in case of IPPD we had used propanol, isopropanol as our solvent as well as reactant, whereas in this case in 6-PPD we have used methyl isobutyl ketone. Alright, and the second thing is that this methyl isobutyl ketone acted as solvent as well as reactant. And the third thing that we used is formic acid. Formula of formic acid is HC double bond OOH. Now these two hydrogen which are there are used for transfer hydrogenation by active sites of palladium on charcoal. So what happens is this goes out, this goes out. So these two hydrogen are actually used for hydrogenation and this goes out as carbon dioxide. Now carbon dioxide, now here it's been shown like this, but it is, as I have shown in PIC, it's a linear structure, carbon, C double bond O, C double bond O, but they are linear structure. Alright, as shown in PIC. There is yet another technical modification which we have to apply. Now as we are adding formic acid as our hydrogen donor, and this formic acid has to be added drop wise, so we use dropping funnel. We also call it as pressure equalizer. Now as formic acid drops in the reaction mixture, the catalyst palladium on charcoal chemi-absorbs hydrogen from formic acid, and carbon dioxide which is left behind is liberated. So yet another modification, that is an outlet for evolved carbon dioxide, also has to be done. In case of 6 ppd, if you observe, all the steps, all the 3 steps are identical to that what we saw in IPPD. Now first of all, let us talk in terms of, now that's the reason why I would be directly jumping to step 2. Alright, in case of step 2, step 1, what happens? The nitro compound which is there, it gets converted to amino. So amino diphenyl amine. So nitro diphenyl amine gets converted to amino diphenyl amine. Alright. Now in this step, in step 2, it is condensation of ketone with amine. Now in case of IPPD, we saw condensation of acetone with amine to give imine. Process is the same. Now there hydrogen donor was isopropanol. Here hydrogen donor is formic acid. Alright, as mentioned earlier. Now let's try to recap the same thing, but with methyl isobutyl ketone. Alright, as we are forming 6 ppd. So let's see what happens. So this is attached here, these 2 double bonds. Now we have got to attach it to carbon. So what we get is what we ended up is with imine. Now we have got nitrogen here, nitrogen and carbon having double bond, which is imine group, and this is again attached to carbon over here. So this is what is imine. Alright, now let's understand how does the next step, that is the final step, that is hydrogenation of imine, occurs. Now in case of hydrogenation of imine, what happens is this double bond has got to get reduced to single bond. Alright, let's see how it happens. So here it is, it combines here, forms single bond. It's got to have one hydrogenation. So this is attached here, hydrogen, carbon also has got to get hydrogenated. Let's see where can I fit it. So ultimately we end up with this. This is our product. So what we have is, we had C double bond N over here. Instead of that we have NH over here and CH2 over here attached to this group. Alright, so this is what is our 6 IPPD. Let's understand what change has occurred owing to oxidation of 6 ppd. When we observe this structure, we find that C double bond O, C double bond O has formed over here. So this has got oxidized. At the same time, we find double bond over here. Now this structure which is there is quinone structure. All right, this structure is a quinone structure. So now it is no more 6 ppd, but it is 6 ppd quinone. Now it has lost all its antioxidant, anti-ozonant property. Rather, we can say that in order to save life of tire, 6 ppd has sacrificed itself. So guys, this is how a novel method of synthesis was explored, in which 3-step 1-pot reaction occurred. Guys, it has been always my pleasure to share my research experiences over here. Hope you also enjoy it. Would also at times share my failures that I experienced during explorations and how it also became a learning lesson. Now it's all rising over shoulder of failures, we move towards success. Alright, so keep viewing and do put in your valuable comments. Alright, see you soon. Thank you.